Oh, good. All right. Send that along. Okay. So we got this target. I asked you, did I give you a height? So this is like 89 meters from here to here. Can you see that lower line? Not really. Okay, to the top of the trampoline, right? For the target. And we said I asked you for the distance to the center of the target. Okay, that was the delta x that we needed to figure out, right? Is that correct? Okay. And so I asked you a couple things. What did I ask you? I asked you for delta x, delta t to impact, the height max, and the what? The final velocity in the y direction, right? No. I asked you for the final velocity total, didn't I? The resultant VB final. Okay. So let's talk about how to do this. All right. Couple of things. The first thing we do always is first before you do that, draw a picture. We've got pictures drawn. Then we can lay out the facts. What's the first fact we want to lay out? The type of motion. Okay. So I have, how many types of motion do we have here? Two. So we've got what directions of motion first? We have vertical and horizontal, right? What are the two types of motion? What's the type of motion that we have vertically? Constant acceleration. What about horizontal? Constant velocity, because we have no air resistance, and we negate that, okay? So, given that scenario, have a seat. Given that scenario, what is my one constant velocity equation that I have? What's my one constant velocity equation I have? Right. Velocity equals delta D over delta T. Everyone with me? Okay. What are my equations that I could use for constant acceleration? I have a few of them, don't I? Give me the first basic one. Say what now?
Velocity final equals velocity initial plus ADT.
Yep, ADT. That's actually the same as delta V over delta T, isn't it?
Wow. Yeah.
Right? Because that's what Sam said was velocity final equals A times delta T plus V initial, right? Well, that's the same thing as this, isn't it? Does everyone see where that came from?
Yes.
Because the delta V is V final minus V initial, right? We're good? Everyone see that? Okay. What's the other big equation we got? This equation relates change of velocity, acceleration, and time. What other relationships do we have for acceleration? We got two more basic ones.
Delta D.
Okay, delta distance. We're relating delta distance.
Equals
V initial
times delta T
times delta T
plus half A times delta
D squared.
T.
Okay? All right? So we've got, this was relating my acceleration, my change in distance, my time, and my initial velocity. What's my last big relationship that I've got? V final squared equals
V initial squared
plus
2A times delta T.
times delta D.
And V.
Right? So these are our basic equations. Does that make sense? Yep. Okay. So these are the ones we can use for constant acceleration. There's basically three of them, ostensibly, right? Okay. All right. So now the question, so these are our facts that we've got so far. The other facts, what other facts do we have? We've got what our values are, right? Now here's the thing, here's the trick. Remember we talked about this table of variables. What are my 6 possible variables that I can use? What are my 6 possible variables? I'm sorry? Okay, let's do a position initial, okay? Your delta x or delta d is really a change in position, right? And you can use y or x, but let's just do it for the y for a moment, okay? We have y initial, what else do we have?
Y final.
Y final, what else do we have? Vy initial. Vy final. What else do we have? 2 more. Acceleration on the y and delta t. Okay? Guys, these are the only 6 possible values you're going to have at the moment. Okay? Now, could this be in the x direction? Sure. It's the same thing. It's my x initial, my x final, my vx initial, my vx final, my ax, and my delta t. Right? Everyone clear with me on that? Okay. The problem is this. With a problem like this table, the values in this table will change depending on what you're looking at. Okay? You have to determine what your initial and final values are. These equations and these values, this table, is valid for any point in time along the motion of the arc. Okay? So I can look at that at any point, and I just have to choose what my v final or my initial position and my final position is. Okay? You guys get that? Right? So if I'm gonna change this for a second. Let's say I have my cannonball and it's gonna go through a trajectory kind of like this, right? Okay. I'm gonna have a couple positions. I've got this position. What are my key positions that I know some information about? The top position, right? What other position do I know? The very bottom is important, right? Because there's going to be some the potential. One more potential interesting place.
In between the side.
Okay, well,
like horizontal from the
yeah, this position here. Why is that interesting? Yeah,
because it's going to take the same time.
yeah, it's going to take the same time to go up as it is to go down. What about the velocities?
They're going to be the same.
The vertical velocities are going to be the same but opposite, right? Same magnitude, right? So whatever my Vy is, this is going to be negative Vy. Okay? Does that make sense? These are important things. What do we know about this guy here? What? My Vy is what? 0 meters per second. Okay? And that's going to be my max height, plus whatever this distance is here, right? You guys with me? And I know that what's interesting about this position is I've gone my full height, and this is my final time, right? Okay. What do we know about the horizontal velocity, assuming no air resistance, for all these positions?
They're the same.
Everyone see that? My Vx is equal to my Vx, which is equal to my Vx, which is equal to my Vx. Everyone with me? As long as I'm not, because there's only one force acting on this cannonball, and what is that force? Gravity. In which direction does gravity pull? Downward only. Does it pull to the side? No, if it doesn't pull to the side, then the cannonball's velocity to the side is the same. Nothing's making a change.
Mr. A, what does that thing in the middle say?
Here? Oh, my max height,
Okay.
right? It's going to be the whole distance, right? Okay. So here's the thing. I know certain things. Some positions give me certain information. I know my vertical velocity up here. I know my vertical velocity here if I know my initial. I know I know that this is the maximum. I know what my final position is here. What's my final position? Y final equals 0 meters. Every point allows me a little additional piece of information. But depending on what my initial and final is, that table is going to change. Okay? Let me get this really fast. Copy. paste. This table is going to change depending on what I'm looking at. Yes, ma'am.
You have to pull the screen down.
I can't because it's not focused to the screen. If you come over here, it'll be much easier to see. Or you come scoot closer in. That's just a bad position. I'm sorry. Okay. Is that better? Yeah. Slightly. Then try over there. That for sure will get you out of the glare. Okay. All right. Cool. And you can scoot in closer. The glare, there's okay. Well, I mean, I can pull the screen down, but it's going to be out of focus at this point. I can't do that right now.
All I'm saying is like right there, there's glare from my seat, there's glare from here, your head's blocking.
Okay, we'll come scoot over. Okay. Come grab it. Come grab here. Here you go. Ready? Grab the stool. Okay. Okay. All right. Okay. Okay. All right. Okay. So here's the thing. Those equations we use, okay, can be used at any point in time during this curve. Okay. I could choose the initial position to be here and the final to be here. Let's call this point A, point B, point C, and point D, right? I could choose my initial to be A and my final to be D. That's going to give me some different things here, especially if I have a specific, let's say I have the height here. Let's say this is going to be H1 from here to here, right? Okay. So my initial position and my final position will be one way if I'm looking from A to D. If I'm looking from A to B, the height's going to be different, isn't it? My Y final is going to be different, isn't it? Right? So you really have to keep that in mind. This is important. I want you to know that when you're going to set your table up, but how you solve the problem, you're going to have to do a couple of different steps. You may have to do A to B first before you can go to D. Okay? But you have to be careful that each time you do it, your table's going to change. Clear? No? Crystal? Okay, good. Okay, so let's do this. Let's do this. Let's say that we're going to look at let's try and solve for our time. Let's see if we can figure out, because I'm looking for let's start with delta x. I'm looking for delta x, right? Let's see if we can figure out delta x right away. Okay? So delta x is using which direction of motion? Horizontal. And what kind of motion do I have? Constant velocity. So which one equation do I use? V equals delta d over delta t. Okay. Right now I have a velocity, don't I? And the velocity is what? 100 meters per second at 30 degrees. So I have to do what with that guy? I got to break it down, okay? So here is V sub b, and here is VBX, and here is VBY. And here's my theta, right? So what is VBX equal to? Give me variables. VBX is equal to what in variables?
Cosine.
VB times the cosine of my angle, right?
Yes, yeah,
Correct?
yeah.
Okay. What is VBY equal to?
Sine.
VB times the sine of theta. Correct?
Okay.
Okay. So that means that it's so VBX is equal to 100 meters per second times the cosine of 30 degrees. What did you guys determine VBX to be yesterday? 30 cosine times 100 is 86.6 meters per second. 86.6 meters per second. Correct? Okay. what is VBY equal to? 100 meters per second times the sine of 30 degrees. Sine of 30 is 1/2. So VBY is equal to 50 meters per second. I want you to see you guys be able to do this on the exam. Gotta break it down. Show me the sections. Okay? If you need more paper, take more paper. Okay? So now that you've got that, okay, let's look and see, okay, so let's see if we can figure out delta x. So delta x means we're using the velocity equals delta d over delta t. Well, delta d is my delta x. Do I have my horizontal velocity? Yes. Do I have, I'm looking for my delta d? Do I have my delta t? No. So can I solve for delta x just yet? No. Got to find the time. So let's see if we can hit the time. Let's see if there's a way of getting time. How can I find my time? Is there a possibility of finding my time? And we're in the time for what? From where to where? From, okay, I'm going to call this point A. Let's call this up here point B. Let's call this over here point C. Well, ultimately, the time for this equation is from which point to which point? A to D. So let's see if we can find the time from A to D first. Otherwise, we can do it what you're doing. You're exactly right. By the way, there's a million ways to do this. There's a million ways. There's no wrong way to do it. Okay? But let's see if we can find the total delta time just yet. So let's list out, let's make a table for A to D. Here's my A to D table. Ready? Y initial. What's my Y initial? 89 meters. What's my Y final?
0.
What's my VY initial? 50 meters per second. What's my VY final? Don't know. What's my acceleration, the Y? Okay, and what's my delta time? Don't know it. Okay, so now let's take this table and see if there's an equation we can use that makes a relationship between the information that we have. May not happen. Let's go look. We're definitely looking for time. Which equations involve time? Well, is time in this last equation? No. So that's the one we can't use. What about in the first two equations? Is time there? Time is there. Good. So we've got a Y initial and a Y final. That's information that we have. We don't necessarily have to use it, but is there an equation that uses delta distance? Okay. So that's that second one. The first one doesn't. Let's look. Then I've got my velocity initial and my final velocity. Okay? The first equation that doesn't use delta distance, what does it use final and initial? And time? That means I'm going to have what? Two unknowns in one equation. So that equation's out. My only hope at this point is that I can use this equation down below. Okay? So let's look. My delta distance I have. Do I have my initial velocity? Do I have I'm looking for my time, right? Do I have my acceleration?
Yes.
Looking for my time? Great, I can solve for my time. Okay? So I can say my delta distance, which is my Y final minus my Y initial, okay, equals my V initial times delta t plus 1/2 A delta t squared. Okay? So what is my Y final? 0 minus 89 meters. It's important that you do this correctly. What's going to matter if I switch my final and my initial?
You get the wrong answer.
You get a positive and therefore the wrong answer. Okay? Make sure you're careful for your signs. Equals what's my initial velocity? What's my initial Y velocity? Positive or negative? Why is it positive? Going up. So 50 meters per second times my delta t plus 1/2 times my what? Okay. Times delta t squared. What kind of equation do I have? What kind? Yeah. See, this is what bothers me about the calculator. It's really bothered me, and I think I've identified what bothers me about these big calculators. The calculators don't let you know how to solve the problem. If you need to know how to solve the problem and you didn't have that calculator, you're done for. That's the problem. That's the problem I see. You should be able to solve this. Every problem I do in this class, you should be able to solve with your calculator on your phone. Simple as that. If you get stranded on a deserted island with only a basic, simple solar calculator, you should be able to solve all your problems and project yourself off the island with the bamboo stretching back to the ship that's 200 meters away on the water, right? You've got to be able to MacGyver your life. Continue with the problem?
Yeah.
Okay. But my point is this.
No, I got you.
Okay, so I ask again, Mr. Dentino. I ask again, what is the type of formula that I have here? What kind of equation do I have? A quadratic. Okay. Thank you. So how do I set this up in the basic quadratic format? Equals 0. So it's negative, I can't do the math in my head, 9.81 divided by 2 is 4.9. So let's say 4.9 delta t squared, right? Plus 50 delta t plus 89. Correct? Okay. And now you can solve for that, right? Now, what were the two options for delta t that you got? What were the two options for? Correct. What does that mean?
That you never use that.
Yes, but it really means this. If this here is my time equals 0, and I'm on a parabola, this parabola, guys, still continues that direction. Okay? It would have been the time that it would have taken to be here earlier. Negative time, right? If I were to continue, if I started here and then let's say I kicked the ball from this position, the entire time, which is my negative plus my positive, both of those together, okay, that total magnitude of time would have been the entire time to get from there to there. You follow me? That negative time is the time that I would have been here.
We don't have to do that on the test.
No. But I want you to know where it's coming from. Okay? So what were my two options? It was what? Negative what? Anyone do it? Give me the answer. Quick, quick, quick. Don't make me go through it because I'm going to do the long formula for quadratic. That's where the power of the calculator comes in.
11.75 seconds.
Was that positive or negative? I think that's right.
Can we just give you the positive?
Give me the positive. What's the positive? So it was 11 point. Yeah, it was 11 point something. 75 seconds. That's the positive value. That is the value from here to here. The time it's going to take to get from A to D. The negative 1 point something was the prior 1 second. It would have been from here to here.
That doesn't make a lot of sense.
It does. Well, it does. It does when you think about capturing your time. Because here's the deal. Though we have a cannon, okay,
Right.
if you were to have been over here and kicked the ball through this point where the cannon is, where it had that exact velocity at that point.
No, I get that you're starting at a point on the parabola.
Okay. All right. But practically, what's the point? Practically, the point is about.
Practically violates thermodynamics. There's that.
Practically, it could be. If you wanted to recreate it. All right, let's move on. You always get a note card on a test. What's the purpose of the note card? 2 reasons. 1, you don't have to. I don't want you to have to memorize stuff because in this day and age you don't need to. 2, what's the second reason? But the more important reason we have a note card. No. Okay. It is a method for which you can study. If you are doing your note card correctly, you are studying while you're doing it, and when you take the test, you don't need your note card. If you've really done it well, you won't need the note card. Right? Trust me, I've done 1 million note cards, and I use like 3 of them. Okay? It's 1 million. That's a lot of them. All right. So that's my time. Now what can I do? What can I do with my time? What can I do with my time? Okay, I'm going to add a new layer here. I'm going to hide this. Okay, so my velocity was my delta distance over delta time, right? And I'm looking, which is really my delta x, right? Delta x. So my velocity was what? What was my horizontal velocity? It was what? 86.6, right? So it's 86.6 meters per second equals my delta x over my delta time, which is now what? 11.75 seconds, right? So delta x equals 11.75 seconds times my 86.6 meters per second. And I notice that my seconds cancel, giving me a delta x of 11.75 times 86.6, which is a kilometer, 1,017 and a half meters, 1,017.5 roughly, or 0.6 meters. That is the distance I have to move that target in order to hit. Does that make sense? Yeah. Ellie, do you want me to go back? Okay. That is the distance I have to put that target to. 1,017.6. Okay. Make sense? Yes. Correct. If I have my cannonball here, right? Here's my target. It's got to be this distance from the center of the target. It's got to be 1,017.6 meters. Does that make sense?
Now that we have time, we can do the other one.
Right. Now that we have time, we can do some other stuff. What other stuff are we looking for? We're looking for the height max and the final velocity max, right? Let's just go. At this point, you can do a couple of different things. Okay, you can solve this a couple of different ways. But how do I get my height max? Let's just go in order. How do I get my height max?
Velocity equals 0.
You gotta look at point B.
Okay, so now in order to do this, in order to do my height max, I'm looking from A to B this time, right? And if I look at my y initial, my y final, vy initial, vy final, my acceleration in the y, and my delta time. Okay? And in this case, because I'm going from A to B, I have some different information, don't I? My initial and final have changed from my prior scenario. So what's my initial y? 89 meters. What's my y final? That's what we're looking for. What's my vy initial?
15 meters per second.
What's my y final?
0.
Okay, what's my acceleration rate? Meters per second squared. What's my delta time? Don't know. Okay? So let's look at this. So I go back and I look at I look at this, okay? So the two things I don't have are my y final and my delta distance. But I'm looking for my y final. Delta time, excuse me. I'm looking for my y final, but I don't have my delta time. So let's go back to my set of equations. What kind of motion, by the way, are we looking for vertically? Okay? Yes, sir. Okay. Yeah, you just... Now, if I knew the distance, I could have figured out the time, couldn't I have, right? If I knew the distance from A to B horizontally, I could have figured out my time, right? Yes? If I knew my distance horizontally from A to B, where B is the apex, couldn't I figure out my time?
Yeah.
Because I have my horizontal velocity, but I don't know that, right? Okay. But right now I have everything but final position height-wise and my delta time. So let's look at my set of equations. Can I potentially use the top equation?
Yes.
I can. I don't have my delta time. I don't have delta t.
You're solving for what's time.
No, I'm solving for the height max right now. Right now I'm solving for height max. We have delta time impact. We have this. I'm looking for height max. Is that you with me?
Just solve for delta time with the height. You know,
Okay.
You have the velocities, you just solve for the times and you put it into
You
position.
can, that's one way of doing it. That's why. Oh, there's another way too, which I'm going to show you here. Oh, there's a million ways to do it. Okay. So, but let's just look at the equation for a second, because that's a two-step process.
Yeah.
We can do it in possibly one. Okay. If I look at this, my first equation involves time. Do I have my delta time? No. To your Sam's point, we could solve for it, but let's see if we don't have to. Okay. The next equation, delta distance, initial velocity, yes, acceleration, yes, but again, time. Okay. The last one is V final, V initial. V final is what I'm looking for. V initial, do I have that?
Yep.
Do I have my acceleration? Am I looking for my, I'm sorry, I have my final velocity. See, I have my final velocity, have my initial velocity, have acceleration. Am I looking for my delta distance? Boom, one step. Okay, so I go back here and I say, all right, I say, okay, so V final, so now we're looking for height max, H max, right? So really, that's this distance here, right? Plus my total distance, plus my 89, okay? So, but really the 89 is going to come into this, isn't it?
Yeah.
Yeah, it's good. So if I use V final squared equals V initial squared plus 2A delta Y, okay, right? So V final, what's V final? What's my final velocity vertically? 0 equals, what's my V initial squared?
50.
50 meters per second squared plus 2 times negative 9.81 meters per second squared times my delta y, which is y final minus y initial, right? This is y final minus y initial. And so what's my y initial? What's my y initial? 89. So it's going to come right into that. That 89 is going to be being taken right into account. So now all I have to do is do a little bit of math, right? So we say 50 squared is 200 plus 9.81 times 2 is 19.62. So it's negative 19.62,
50 squared
isn't it?
50 squared.
50. Did I not do that right? 2,500. I'm sorry. 50 squared. 2,500. Thank you. 2,500 plus a negative 19.62 times y final minus an 89 times that, right? So 89 times 19.62, right? So that's 1746, but it's minus times minus, so it's positive 1746.18. Do you guys see that? Okay. So now all I have to do is solve for equals 0, right? So all I have to do is solve for YF. Okay, so YF is going to equal, and I'm going to say that plus 2,500, okay, divided by, and then I'm going to make a negative because I'm going to move to the other side, right, negative, divided by 19.62 negative, oops, try that one more time, 1746.18 plus 2,500 negative divided by 19.62 negative equals 216.42 meters. 216.42 meters. From where? From what? From where? Where is 216 from? From A or from the ground? From the ground. Because doing this, guys, it's already taken into account. Now, could I have put 0 here? Yeah, that would have given me the height from here to here. Right? That's a delta distance, right? But we're looking for is at 89. 89 taken into account.
So that's the height.
That's the final position, final y height. You guys see that?
Yep.
No, you see that? No? Which part don't you get?
Wait, so that's the height of B?
That's the height
Of like,
at B, the max height.
Yeah.
Because
That's like 260.
216.42 meters.
Max height.
The max height.
How's that?
That's concerned.
How's that possible?
89 is not watching.
Yeah, that doesn't make a whole, well, I mean, I guess.
Wait. Oh, that's before that.
Yeah, it's 89. It's 80. It's not 216 above the 89. It's 216 total from the ground.
So 8 to the ground is 89, but like 8 is 2.
Right. So the distance above is minus 89 is 127.
Oh, so it needs to say not to scale.
It's not to scale, guys. Yes, it's not to scale. And maybe my math's off. Let's just redo the math. Let's make sure I did the math right. Let's make sure I did the math right. So it's 50 squared, 25, right? And then I've got 19.862, that's correct. And then 19.62 times 89. Yeah, that's right. Yep. Plus 2,500 divided by 19.62. Okay, 260. The reason it's so high, the reason it goes so high is we have 15 meters a second up.
Where is the 1,346.1?
Where does this come from?
Yeah.
Okay, this comes from.
Yeah.
So I'm taking the 2 times 9.81, which is 19.62, and multiplying times YF and times 89.
Oh.
You follow me? Okay. So I'm taking 2 times that, multiplied by YF, 2 times this times 89. And so because it's negative, because the 89 and the 9.81 are negative, then I get a positive, right? Now, okay. So it seems pretty high, but I had a 50 meter a second initial velocity. Doesn't take to go 100 and something meters. Only takes a couple of seconds. Can you stop that, please? Okay. Does that make sense? You guys see that? So it's gonna go because I've got a pretty decent angle. Okay, all right. So you can solve that, continue to solve that, okay? No, it's all about the graphing that we did earlier. You guys, listen up. I'm going to be very clear about this. Shh, listen. We didn't cover this today, guys.